Thank you for tuning in, everyone. Welcome to the June 25th virtual Time Series Meetup. We are glad that you're able to join us. As a reminder, if you have anything that you'd like to share or ask as we go along, please feel free to use the chat and the Q&A option, which you'll see on your screen in the Zoom menu. It is, after all, a community call, so we want to encourage everyone to ask questions, share your comments, and participate in the conversation as we go along. Uh, if you have anything that you'd like to just comment on, you feel free to use the chat feature. And if you have any questions directly related to our speaker, go ahead and use that Q&A feature and we'll circle around to those questions at the end of the talk. It can be a little bit difficult to recreate the conversational magic that we get from meeting in person, including like the interacting and the networking that happens. So I really want to encourage everyone to use that chat feature to its fullest, introduce yourself to one another, make friends. It's really a great way to kind of get the conversation going and kind of recreate some of that sense of community that we miss from meeting in person. Also, if your company is hiring or you know of companies that are hiring, there will be a section of the call after we finish our talks where we do a virtual job board, and we want to encourage everyone to share any open positions and hiring opportunities that your company has with our other Meetup community members. And today we are joined by Andrew Brower, who will be speaking about using a Raspberry Pi cluster to monitor with InfluxDB and Telegraf. Should be a fun talk. After the presentation, we'll do a quick Q&A break with the audience. So feel free, as I mentioned earlier, to post your questions as we move along using the Q&A feature in the Zoom window. And we'll go ahead and get to those right after the conclusion of the presentation. After the talk, we'll also share some announcements and some job opportunities with the group. And if you're aware of any open positions, please do remember to add those in so that everybody can take advantage of them. And finally, we will conclude with a swag giveaway. We have some really cool goodies to give out today, such as InfluxDB socks, some Influx t-shirts, and even hoodies. So a lot of fun stuff, so stick around for that. Additionally, thank you all for registering to join the Zoom webinar. Anytime we do these Zoom webinars, it requires us to do a registration. But I do want to remind everyone that this is a community event and your information is not going to be used for marketing purposes. This list is just helpful for us when we do the swag raffle. It allows us to reach out to you after the call and gather your shipping information. But after that, we will not be retaining the data. So rest assured that your data is safe with us. I personally delete everyone afterwards, so no worries there. So yeah, our guest presenter today is Andrew Brower, as I mentioned a moment ago. Andrew and I first crossed paths at the San Francisco Time Series Meetup back at, I believe it was February, at the beginning of the year. He's a great guy who loves 3D printing and is passionate about DevOps, monitoring, and security. Today, he'll be speaking about using a Raspberry Pi cluster to monitor using InfluxDB and Telegraf. And we'll get to Q&A just after the conclusion of that. So feel free to post your questions for Andrew. Thank you so much for joining us, Andrew. We're delighted to have you. Are you ready to begin sharing your screen?
I sure am.
Cool. I'll go ahead and stop now.
Everything looks good?
Looks good, yeah.
Sweet. Okay, hello, I'm Andrew Brower, and I'm going to be talking about my Raspberry Pi cluster and monitoring with Influx and Telegraf. So I'm currently working as a senior software engineer at Human Interest. However, I don't do very much for DevOps with my day job. But previously at my university, I worked for a Penguin Computing Linux cluster of GPU accelerated servers. This was a really fun job because my boss did not let me use any tools other than Bash and SSH. So I had to get really good at writing Bash scripts. In my free time, I love 3D printing. I built my own 3D printer from a kit, and I totally recommend it. It's really fun and affordable. I love messing with DevOps, monitoring and security for hobby projects. At one of my previous IT jobs, I got to work with a tool called Nagios, and it was a cool monitoring tool that felt like a superpower. I would know that something was down before anyone else had even noticed. For an example of that, one time I got an alert on my phone that one of our servers was overheating. And so I connected in and I saw that temps for the entire cluster were slowly rising, and that the air conditioning in the room had failed. So I ran a script that I had prepared already to safely shut everything down. And then an hour later, I got a call from my boss saying that building management called him to tell him that the air conditioning failed, and he told me to get everything shut down. And I had everything already handled before he was even aware there was an issue. So monitoring is pretty fun. So I'll warm you guys up with a question. Um, what are some cool Raspberry Pi projects that you guys have done? Or other than that, what cool projects have you seen other people do? Um, Please think of all these questions and we will come back to them later. And so I will be talking about the fundamentals of what a cluster is and why they are cool, along with the steps of setting up all the hardware and software for a cluster. How I've been using my cluster to monitor using Influx and Telegraf, along with all the different possibilities of different use cases and further improvements that could be made. So a Linux cluster is a group of similar computers running Linux that are all networked together. How a cluster is set up can vary a lot, but I'll be describing what they are generally like. To users, the cluster kind of acts like one giant computer. Each computer is called a node, and there is usually a leader node that the users actually connect into. They usually have some sort of shared storage that's available on every node, and that shared storage lets all the different nodes read and write to the same directories and share the work that they were operating on. And the clusters usually don't have any sort of monitor or mouse and keyboard. Everything is done over the network. Uh, Typically, this is done using tools like SSH. SSH lets you connect remotely over the network and run commands. Um, and so users define what work they want to get done, and software on the cluster handles automatically assigning that work to the different nodes that it may need to run on. For a simple example, a user may want to calculate 4,000 digits of pi. And so calculating the first 1,000 digits might go to node number 1, calculating the next 1,000 to number 2, and so on. Another cool feature of clusters is they can usually handle node failures. If a single node in the cluster goes down, the work that was being done on that cluster on that node can be automatically reassigned to another node to finish. This means that maintenance can be done on individual nodes in the cluster without having to take the entire cluster offline. The photo on the left is a picture of a cluster that Oracle recently built that featured 1,060 Raspberry Pis. And the picture on the right is a photo that I took of the GPU accelerated cluster that I helped run back in college. Clusters can come in all sorts of different shapes and sizes. Some, like mine, can fit in the palm of your hand, while others might take up an entire data center. And so let's get started with some of the basic things that I'll be talking about with this presentation. The Raspberry Pi is a small, low-power, cheap ARM computer that can run Linux. It's the small little green thing in the photo. And a Raspberry Pi cluster is really great for learning because this entire cluster that I made only cost around $200. My goals for this was to just use it for learning, and I wanted to keep the project simple with the aim to finish this whole cluster within a couple of days. That helped me decide what software I wanted to use for the cluster. This project happened a year ago, so it's possible things have changed since then, but I think a lot of it is still relevant. So I decided to go with using Docker to handle running the work on each individual node. And the first thing I wanted to get running inside of Docker was InfluxDB to handle storing all the monitoring metrics. And InfluxDB itself only has to run on one node in the cluster. The other big part of monitoring is the Telegraf, and Telegraf is an agent that can run on each individual node in the cluster. So it runs on each node, and then it can send metrics back to InfluxDB to store and review later. So I checked up online and I found a stackable 3D printed case for the Raspberry Pi, and I printed a couple of these. That's that little blue frame for each Raspberry Pi that stacks up together. I totally recommend getting a 3D printer. It's not too hard to build one from an affordable kit. Some examples, things that you could do is you could use it to print any kinds of projects you want to work on, or even print more 3D printers if you wanted to. So for my cluster, the entire thing is organized as a stack. At the very bottom, I started with a 6-port USB charger, and on top of that is a networking switch, and then I have 4 Raspberry Pis above that. For attaching these different parts together, I have strips of Velcro glued onto the switch into the charger, so it holds everything together, but if I want to work on it, I can just pull the Velcro apart and work on each part individually. Luckily for doing the networking, I already had all the tools for crimping Ethernet cables, so I just made a couple of these adorable, really, really short Ethernet cables that just swoop around and look pretty fancy. But one of the exciting parts was setting up the power cable. I have a picture of that there in the middle. You might notice that cable doesn't look very standard. I specifically ordered a 5-volt switch, and I cut the cable for the power adapter and spliced it onto a USB cable. So the switch is powered by the USB charger, and this means that the entire cluster only has one power cable that has to get plugged in. Everything, including the switch, runs off of the USB charger. If you do this yourself, I recommend being very careful, because if it's done wrong, the magic smoke inside of the electronics might get released. After getting all the Raspberry Pis unboxed, I got them set up with Raspbian Linux on each of the SD cards and enabled SSH so that I could connect into each Pi over the network and run commands. And that was the limit of the manual setup that I had to do. Just getting the Pis set up and getting them enabled with SSH. The rest of the entire process I had automated. So with all the hardware out of the way, and after I had confirmed that everything was working properly, the next step was getting all of the software set up. So Ansible is an automation tool that can run commands over SSH. The way that it works is you define a playbook of the order of the things that you want to get done. For example, in one of my playbooks, it starts off with installing Telegraf, then updating the configuration for Telegraf, and then making sure that the Telegraf daemon is running on each node. I really love using Ansible for Raspberry Pis because it means that I don't have to install any extra programs. Ansible only has to be installed on my personal laptop, and it does everything over SSH. After Ansible is done running, it runs commands in each node. After that's all done, it is completely done running. It does not need any sort of user agent to be left running in each node. Since nothing has to be left running continuously, that means that there's more CPU and memory available for running jobs on the cluster. So I used Ansible, and I wrote a few playbooks to handle automatically configuring a cluster. One of the first playbook that I worked on was to set up something called GlusterFS, which is used to make a shared file system across the entire cluster. GlusterFS is pretty cool in that it lets you take, in this case, it let me take the free space on each node. Each one had its own SD card, and create one giant shared network storage that the entire cluster could use. So any node can read and write to this giant shared GlusterFS storage. But unfortunately, with how I configured it, this also meant that if one node went down, that the entire storage pool went down. A better alternative could be to enable redundancy in GlusterFS, or possibly to have extra Raspberry Pi nodes that are dedicated to storage, for example, with a attached USB drive for more space. Then I made a playbook to handle setting up Docker Swarm on a cluster. Docker is a really nice way to package up all of the dependencies for the different services that you might want to run. For example, rather than having to deal with installing multiple versions of, say, Python and Ruby and all the dependencies that you may need, having to install that in each node individually, you can package up your service and all the dependencies into one single Docker image. And then that image can be deployed to any container to run on its own, regardless of what happens to already be installed on that node. And Docker Swarm lets the entire cluster appear like one giant machine for Docker to use. When you tell it to run containers, it handles automatically assigning those containers to the nodes that they need to run on. And it also handles the networking between containers. So it doesn't matter if two containers are running on the same machine or if they're running on separate machines. They can still talk to each other without any extra work needed. A possible alternative to this could be to use Kubernetes. However, when I was working on this project initially, I found that it was difficult to get Kubernetes working on the Raspberry Pi. I know that it's much easier to do this now, and that could be an option to make a whole new cluster. But the other thing was, Kubernetes also has a learning curve, and Docker Swarm is a bit easier to understand and debug. And by keeping it simple, this helped me reduce how much time I had to spend on the project. Yeah, and so with Docker working on the cluster, the next step was getting all of the services that I wanted to run stood up. So I wrote a Docker compose file that listed all of the different Docker containers that I wanted to run. This included InfluxDB, and this was using, I set up InfluxDB to use the shared GlusterFS storage for storing all of the cluster metrics. It also set up a chronograph to use as a dashboard so I could visualize all of the different metrics on a cluster. And I also set up a GitLab continuous integration runner. And this gave me a way to like simulate a workload on a cluster. I could have it run continuous integration tasks to give it some sort of a workload to do. So after I had InfluxDB up and running, I could then start configuring Telegraf to collect data and push it into Influx. So I wrote a Ansible playbook that would handle SSHing into all these different machines and getting Telegraf installed and configured on each node, and configured to let it know to send all the metrics back to the Influx running inside of Docker. And so what could go wrong but give a live demo? So I can switch my window and show chronograph. Can you guys see chronograph okay?
We sure can.
Perfect. So here are some metrics in the last 24 hours. We can see that most of the time the cluster wasn't doing very much. It was about like 300 megabytes of memory in use. We got a couple of spikes here, and these were spikes when I was running continuous integration for some of my hobby projects. And so we can just drill into here and look at different segments of time and look at different time spans. It's really fun just to dig through all the different metrics that are going on. And sometimes like you might notice like weird little spikes and you'll be like, what was happening there? Like I wasn't running anything at that time. It's cool to look at all this stuff. And you can set up like different kinds of alerts and other exciting things to do. And yeah. back to the presentation. Yeah, so some cool different use cases for a cluster like this. One of my, so I guess going back to using continuous integration, one of my friends wanted nightly builds of the experimental branch of a programming language called NIM. He wanted to use NIM for compiling programs on a Raspberry Pi, but building the compiler itself on a Raspberry Pi took a while. So I set up a continuous integration runner for every night. It would build a fresh new Docker image of the experimental branch for him to use. So that all that he would have to do is to pull down this Docker image, and he would have a fresh version of the compiler with all the experimental features for him to use that day. Another cool option could be to use it to run cryptocurrency nodes. For example, with Bitcoin, you could attach a USB hard drive, and that hard drive could store the blockchain, and you could run the Bitcoin node software on one of the Raspberry Pis. But probably one of the coolest solutions that I thought about was using it for home automation. There are a lot of cool different services for home automation, like a tool called Home Assistant. And being able to run this on the Raspberry Pi cluster could be a really fun use case. Have it connect to all of your Internet of Things devices and maybe like track all the different metrics, influx, and you could just have a whole different stack of services running on this cluster. Yeah, so I'll go ahead and share the link to the blog post explaining exactly all the different steps used for building my cluster. This includes, the blog post has a link to the GitHub repository that has all of the source code that I used in this project. But also during the process of making this presentation, I've been wondering what could be next. It could be, this cluster was made using the Raspberry Pi 3, but it could be really cool to make a new cluster using the Raspberry Pi 4. This would allow for a number of different improvements. For example, it could make a cluster using power over Ethernet to reduce the number of cables that I needed. You'd only need one cable for each Pi for the networking and power. It would also be really cool to see a cluster set up with Pixie network booting. That way each Pi would not need to have its own SD card, but instead each Pi could just boot over the network. That would help save money. You wouldn't need so many SD cards, and it would also make deploying updates to the cluster easier, as you could pre-package the image that you want to push each cluster over the network and update it. It could also be cool to run Kubernetes on it, since it has matured a lot over the last couple of years. I know I've also had a project called K3S, which was a light version of Kubernetes. So that could be cool to look into. And that is it.
Awesome. Thank you so much, Andrew.
Oh, whoops. Share it to the, had the wrong default. Oh, there we go.
Great. And Subir, I believe you were asking the link, if that's the link to the blog post. Caitlin just posted that in the chat for you. Yep, that's it. Okay, great. Glad we were able to provide that for you. And Andrew, if you would stop sharing your screen, I'll go ahead and take back over. And we'll take a pause now for some Q&A. As a reminder, use the Q&A window, which you'll see on your Zoom panel, to ask any questions that you'd like. Our first question that came in is from Ignacio. Have you used the Raspberry to get temperature and humidity data?
Ooh, that is exciting. So I started working on this like one day, but I didn't actually get around to finishing it. I do have like a couple of temperature and humidity sensors, but I haven't set them up with a Raspberry Pi yet. That would definitely be really cool, though. I would love to see that.
An anonymous attendee asks, what do you use for your log
Mm.
server?
Ooh, that's a really good question. I have not set up a centralized logging server. That would be really cool to look into, though. Um, I know in the past, like I looked at. Oh, I think I remember that I was looking at Splunk, but I'm not sure if they have a version that can run on the Raspberry. They might have a version now that can run on the Raspberry Pi, but they might not have had one when I was working on this project initially. There's definitely lots of options. Like maybe you could just use like a simple syslog setup or something.
And can you tell us about the primary limitations that you've run into with this using this setup?
Limitation, yeah. So the Raspberry Pi 3, it doesn't have a whole lot of memory, and getting a whole Docker container set up, like using if you're using like Alpine Linux, it can make it much more compact. But I've definitely had some times where like I'd be running into memory limitations. But the new Raspberry Pi 4 has much more memory, which makes it easier to run like lots of containers. I think the other big hurdle that I've ran into is that like a lot of things like Docker containers, for example, assume that you're going to be running them on x86. So when I was first building this cluster, sometimes I would have to recompile things specifically for the Raspberry Pi 4. Um, but however, I noticed that when I was working on this cluster in the last couple of weeks, that at least looking on Docker Hub, there are a lot more options for all the different architectures for Docker images.
Great, thank you so much. John asks, some of the hardware seems to be in short supply these days. Any suggestions on the best source to purchase one, such as the Pi 3B Plus?
Mm. So I don't think I have a good answer for this. I know in the past what I've done is that sometimes like nearby I know like certain specialty electronic stores. They might be completely sold out online, but I know that some of these stores like people don't think to go there for Raspberry Pis, and I could pick them up in person at a physical store. However, I really don't know these days.
Great. Do we have any additional questions for Andrew? Let me go ahead and check the chat just in case any other questions have come in through there. Great. Well, thank you so much, Andrew. We really appreciate it. And we'll go ahead and continue on to the announcement section. Here at InfluxData, and particularly the Time Series Meetup, we are all about community and growing the Time Series community in general. And I certainly know that if you're like me, a lot of us have been getting bored with staying in all week, week after week. I know there's certain regions that are starting to open back up and allow for getting out and kind of socializing, but many of us aren't. So we want to encourage everyone to get out, join the community, stay productive, and stay involved during these dreary times. Um, it's super important to maintain that sense of connection, I think, now more than ever. So if you're looking for something to do, you want to use the extra time that you have on your hands to learn a little bit more about time series data, then I encourage you to hop on over to the InfluxDB community page, which can be found at influxdata.com/community. It's a great place to poke around, ask questions, find help if you're looking for it, learn about solutions, share your ideas, and follow along with other discussions. We also have, if you're looking for perhaps some help or some great place to talk to other community members, we have our Slack workspace that is open to the whole community. It can be accessed at influxdata.com/Slack. It's another great place to meet other community members, to share your knowledge with people, and to get help from not only community members, but staff. And even if you don't have a technical issue or support question, we encourage you to come by the Slack, join the community channel, introduce yourself, and just get to know the other members of the community. Also, I want to encourage anyone that's listening or tuning in today, if you've been working on something related to time series data and you'd like to share it with the time series community, then please do let us know. That's how we were able to get introduced to Andrew, and I think we really enjoyed him coming out and sharing his project with us. It's really cool, really clever. So we're always looking for great people who'd like to speak and share about what they're currently working on. You can let us know if you're interested by using the Q&A feature now, using the chat box, or by reaching out via email at mellis@influxdata.com. And also just a really cool quick announcement. We recently launched Influx Community Templates. So templates provide a way for users to share their configurations with others and work together to enhance and improve them over time. So just like you would any other open source project, um, it's a feature that made a lot of sense for us since many of our users have the same or similar use cases. So if you're interested in learning more about templates, you can pop over to the community page where you can learn more, publish your templates, and see what other InfluxDB users have been able to build and share. So check those out and try them for yourself. And another quick announcement. This week we hosted Influx Days. I know I see a lot of people in the chat who are able to actually, I recognize the names from the Influx Days chat just these past couple of days. So thank you so much for tuning in and joining us here today. We had lots of great talks and presentation from various people at various companies, InfluxDB staff, and community members. If you were not able to catch the conference, we have another online event coming up in November. It's going to be the Influx Days North America virtual event. It's going to be held November 10th and 11th. And the CFP for the November Influx Days is currently open. And we're looking for great speakers from the community. So if you're interested in presenting at a virtual conference, please hop on over to influxdays.com and to learn more and submit your CFP. And now it's time for our virtual job board. So one of the things that we love to do at all these meetups is to share open positions and job opportunities at our respective companies. It's super important now more than ever, as some of us might be between positions and looking for organizations that are still actively seeking employees. So if your company is hiring, please use the chat feature in the Zoom room to share that with the group. Let us know the name of the company, the types of roles that might be open, and whether or not the position is remote friendly, since many of us are joining from all over. I know I can say that here at InfluxData, we are still actively hiring, and we're actually ramping up hiring in a big way. We currently have over 20 engineering roles that we're looking to fill. We're looking to fill several DevOps, site reliability roles, as well as various software engineering roles on the compute and storage teams. We are also looking to fill numerous full stack developer roles. We are a remote-friendly company, and all qualified applicants are welcome and encouraged to apply. You can check out the full list of careers that we have available and positions that we have available at influxdata.com/careers. So I want to encourage everyone to check those out if you're interested in looking. And if you know of any roles that people might be interested in, go ahead and share those via the chat, and we will move forward to our swag giveaway, which is one of my favorite times, hopefully one of yours as well. Andrew's going to be helping us out with this today. So for this meetup, we're going to do something a little bit different. Worked out really well last time around, and we're going to kind of try and do that again. So the way it'll work is we'll determine some winners right now here live on the call, and we'll mark those names down. After the call, we'll reach out via email to each of the winners and gather your shipping information. Andrew, would you remind the viewers one more time what the swag questions will be?
Yeah, so the question was, what cool Raspberry Pi projects have you done? Or if you haven't done any, what are some cool ones that you've seen?
So everyone can take a moment and provide your answer in the chat. And what we'll do is we'll have Andrew pick some of his favorites from those. And we'll go ahead and we've got socks, shirts, hoodie. So let's do for the hoodie, we'll do your absolute favorite answer. And then we'll do the shirts next, and we'll do socks for participation. How's that sound, Andrew?
robotic arm to play chess? Oh, that sounds amazing.
We've got some answers coming in. Capturing real-time robot data.
Ooh, retro gaming. I love retro gaming. I made a 3D printed Pi Portable for retro gaming. Yeah, Pi-hole is a really cool project. It's just so nice to have something on your network that can just suck all the all the ads out of your system. Just block all those ads and trackers.
We'll give everyone maybe another 30 seconds to
Ooh,
submit their answers. And I've got a +1 for retro gaming. I've got a Raspberry Pi that emulates the old NES games. It works really well. It's fun.
Ooh,
My son
sensor data
uses
from a
Raspberry Pi
motorcycle.
to get past a tough place on his N64 game. He wired one of the ports into a controller and programmed the key clicks necessary to get through the tough spot. That's a hilarious answer. For scraping and ingesting weather data. It's collecting sensor data from motorcycles. Lots of great answers coming in. And yes, if you have any blog articles about the projects that you've worked on, go ahead and share those with the community as well. Thank you, Angelo, for sharing that. And thank you, Dave. Oh, wow. Building Alexa. Oh, that's hilarious.
Oh,
Okay,
I
Andrew, do
completely.
you
That
want to go
reminds
ahead
me
and
of
pick
another
your
project I
favorite?
worked on. I made a talking toaster. You could tell the Raspberry Pi to make you toast, and it would proceed to make toast for you.
That's hilarious.
I don't recommend making that project. It's a complete fire hazard.
Okay, Andrew, who do you think should be the winner of our hoodie today?
I think I picked too good of a question because these are all really great answers.
That's very true. Good thing we have we got lots of goodies to give away. So
I think I'll go with the robotic arm to play chess, just because the robotic arm is amazing and having it actually play chess. that's pretty clever.
I'll double check. Was that Angelo? He's saying yay. Yeah, it was Angelo. Okay, so
Yes.
Angelo, we'll reach out to you for that hoodie. How about you pick us a couple of t-shirt winners?
How many t-shirts was it?
Let's do 2 t-shirts.
2 t-shirts. Okay, I'd have to go with. Let's see here. Oh, he's all such good answers. For one of the t-shirts, I have to go with Graham. Capturing real-time robot data. That sounds really exciting. And I also have to go with James and collecting sensor data from his motorcycle. I wonder what that sensor data from a motorcycle looks like. That sounds cool.
All right. And what we're going to do is reach out to everyone else who participated in the questions, and we're going to send some InfluxDB socks out to you. So let me just take a moment to make sure I'm capturing all these names because our chat history will disappear when we end the call. So bear with me while I do that, and you'll hear a little clickety click in the background. Okay, I think I made sure to capture everyone there. So thank you all so much for participating. I really enjoy the swag giveaway time. Yeah, and thank you everyone for sharing your cool projects. I agree. And one more time, I just want to say thank you to everyone for tuning in and joining us. We hope that you can catch us live for the next Time Series virtual meetup, which is taking place July 21st. In July, we will be joined by Marco Letic from Mozilla. Marco is a Mozilla tech speaker, and he will be presenting a talk all about data visualization, the history, and the capabilities of it. So it should be pretty interesting, and you can hop on over to the influxdata.com/community page and click on the Time Series Meetups to learn more about the upcoming event and register. So thank you so much, everyone, for tuning in. We're delighted that you could join us, and we hope to see you again.